abilities. This topic remains, then, an important one for future research. 1.5 Kinds of facial displays. Let us turn now to the use of the face during conversation. Like hand gestures, facial displays can be classified according to their placement with respect to the linguistic utterance and their significance in transmitting information, Scherer 1980. When we talk about facial displays, we are really most interested in precisely timed changes in eyebrow position, expressions of the mouth, movement of the head and eyes, and gestures of the hands. For example, raised eyebrows and a smiling mouth is taken to be a happy expression, Ekman and Friesen 1984, while moving one's head up and down is taken to be a nod. Some facial displays are linked to personality and remain constant across a lifetime, a wide-eyed look. Some are linked to emotional state and may last as long as the emotion is felt, the downcast eyes during depression. And some are synchronized with the units of conversation and last only a very short time, eyebrow raises along with certain performatives, such as implore. EBSCO host, printed on the 2nd of May 2021 1:08 am via Tamperine, Iliapiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 18. In addition to characterizing facial displays by the muscles or part of the body in play, or the amount of time that they last, we can also characterize them by their function in a conversation. Some facial displays have a phonological function, for instance, lip shapes that change with the phonemes uttered. It has been shown that such lip shapes can significantly improve the facility with which people understand talking heads. Bregler et al. 1993. Masao et al. Chap. 10. Some facial displays fulfill a semantic function, for example, nodding rather than saying yes. Some facial displays, on the other hand, have an envelope, for or conversational process-oriented function. Examples are quick nods of the head while one is listening to somebody speak, or a glance at the other person when one is finished speaking. Still other functions for facial displays are to cement social relationships, polite smiles, and to correspond to grammatical functions, eyebrow raises on pitch-accented words. Note that the same movements by the body can have two or more different functions. Smiles can serve the function of emotional feedback, indicating that one is happy, or they can serve a purely social function even if one is not at all happy. Nods of the head can replace saying a yes, the content function, or simply indicate that one is following, even if one does not agree with what is being said, an envelope function. 5. 1.5.1 Cultural differences. Like emblem gestures, facial displays with a semantic function can vary from culture to culture. To indicate agreement, for example, one nods in the United States but shakes one's head in Greece or Albania. However, like beat gestures, facial displays with a dialogic function are similar across cultures. Thus, although generally one looks less often at one's interlocutor in Japanese conversation, conversational turns are still terminated by a brief glance at the listener. And even though semantic agreement is indicated by a shake of the head in Greece, feedback is still accomplished by a nod. As with gesture, then, there are more similarities in the use of the face than there are differences, at least with respect to the regulatory conversational function of these behaviors. In the remainder of this chapter, we concentrate on the facial behaviors whose description has more universal validity. 1.6 Integration of verbal displays with spoken language. As with hand gesture, facial displays are tightly coupled to the speech with which they occur. EBSCO host, printed on the 2nd of May 2021 1:08 am via Tamperine, Iliapiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 19 1.6.1 Temporal synchronization. Synchrony occurs at all levels of speech, phonemic segment, word, phrase or long utterance. Different facial motions are isomorphic to these groups, Condon and Oskton 1971. Kennon 1974. Some of them are more adapted to the phoneme level, like an eye blink, while others occur at the word level, like a frown. In the example, do you have a checkbook with you? A raising eyebrow starts and ends on the accented syllabled check, while a blink starts and ends on the pause marking the end of the utterance. Facial display of emphasis can match the emphasized segment, showing synchronization at this level. The sequence of head nods can punctuate the emphasis, as when one nods while saying the word really in the phrase, I really want this system to work. Moreover, some movements reflect encoding-decoding difficulties, and therefore coincide with hesitations and pauses inside clauses. Aditman 1974. Many hesitation pauses are produced at the beginning of speech and correlate with avoidance of gaze, presumably to help the speaker concentrate on what he or she is going to say. 1.6.2 Facial display occurrence. As described above, facial displays can be classified according to their placement with respect to the linguistic utterance and their significance in transmitting information. Some facial displays have nothing to do with the linguistic utterance, but serve a biological need, wetting the lips or blinking, while some are synchronized with phonemes, such as changing the shake of one's lips to utter a particular sound. The remaining facial displays that have a dialogic function are primarily movements of the eyes, gaze, eyebrow raises, and nods. In the following section, we discuss the co-occurrence of these behaviors with the verbal utterance. Facial behavior can be classified into 4 primary categories depending on its role in the conversation of Argyll and Cook 1976. Chauville 1992. Collier 1985. The following describes where behaviors in each of these 4 categories occur, and how they function. Planning. Planning eye movements correspond to the first phase of a turn, when speakers organize their thoughts. The speaker has a tendency to look away in order to prevent an overload of visual and linguistic information. On the other hand, during the execution phase, when speakers know what they are going to say, they look more often at listeners. For a short turn of a duration of less. EBSCO host, printed on the 2nd of May 2021 1:08 am via Tamperine, Iliopiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 20 then 1.5 seconds. This planning look away does not occur, and the speaker and listener maintain mutual gaze. Comment, accented or emphasized linguistic items are punctuated by head nods. The speaker may also look toward the listener at these moments. Eyebrow raises are also synchronized with pitch accents. Control. Some eye movements regulate the use of the communication channel and function as synchronization signals. That is, one may request a response from a listener by looking at the listener and suppress the listener's response by looking away. These behaviors occur primarily at the ends of utterances and at grammatical boundaries. When the speaker wants to give up the floor, she gazes at the listener at the end of the utterance. When the listener wants the floor, she looks at and slightly up at the speaker. Feedback. Facial behaviors may be used to elicit feedback and to give it. Speakers look toward listeners during grammatical pauses and when asking questions, and these glances signal requests for verbal or nonverbal feedback without turning the floor over to the listener. Listeners respond by establishing gaze with the speaker and or nodding. The feedback elicitation head movements are referred to as within-turn signals. If the speaker does not emit such a signal by gazing at the listener can still emit a back-channel or feedback signal, which in turn may be followed by a continuation signal by the speaker. But the listener's behavior is dependent on the behavior of the speaker. One is much less likely to find feedback in the absence of a feedback elicitation signal. Duncan 1974. In the description just given, facial behavior is described as a function of the turn-taking structure of a conversation rather than as a function of information structure. This is the way that facial behavior has been described in most literature. In fact, gaze behavior has come to represent the cue-to-turn organization, and has been described as if it were entirely predicted by turn organization. However, turn-taking only partially accounts for the gaze behavior in discourse. Our research shows that a better explanation for gaze behavior integrates turn-taking with the information structure of the propositional content of an utterance, a Castle, Torres, and Prevost N.E. Specifically, the beginning of EBSCO host, printed on the 2nd of May 2021 1:08 am via Tamperine, Iliapiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 21. Themes are frequently accompanied by a look away from the hearer, and the beginning of reams are frequently accompanied by a look toward the hearer. When these categories are cotemporaneous with turn construction, then they are strongly, in fact, absolutely, predictive of gaze behavior. That is, when the end of the theme corresponds to the end of the turn, then speakers always look toward their listeners in our data. Why might there be such a link between gaze and information structure? The literature on gaze behavior and turn-taking suggests that speakers look toward hearers at the ends of turns to signal that the floor is available, that hearers may take the turn. Our findings suggest that speakers look toward hearers at the beginning of the ream, that is, when new information or the key point of the contribution is being conveyed. Gaze here may focus the attention of speaker and hearer on this key part of the utterance. And, of course, signaling the new contribution of the utterance and signaling that one is finished speaking are not entirely independent. Speakers may be more likely to give up the turn once they have conveyed the rhetoric material of their contribution to the dialogue. In this case, gaze behavior is signaling a particular kind of relationship between information structure and turn-taking. It is striking, both in the role of facial displays in turn-taking and in their association with information structure, the extent to which these behaviors coordinate and regulate conversation. It is clear that through gaze, eyebrow raises, and head nods both speakers and listeners collaborate in the construction of synchronized turns and efficient conversation. In this way, these nonverbal behaviors fill the function that Brennan and Hultin in 1995 suggest is needed for more robust speech interfaces. 1.7 Another example. Let us now end with another example from life. This excerpt from a human speaking will show the rules we have just discussed in action. Figure 1.2 shows Seymour Papert talking about embedding computing in everyday objects and toys. He breathes in, looks up to the right, then turns toward the audience and says, "A kid can make a device that will have real behavior, that two of them will interact in a to do a dance together. When he says make a device, he looks upward. At real behavior, he smiles. On will interact, he looks toward the audience, raises his hands to chest level, and points with each hand toward the other as if the hands are devices that are about to interact. He holds that pointing position through the speech disfluency. EBSCO host, printed on the 2nd of May 2021 1:08 am via Tamperine, Iliapiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 22. Figure 1.2. Will interact and then, while saying a dance together, his hands move toward one another, and then away, as if his fingers are doing the tango not shown. He then looks down at his hands, looks to the side, and pauses, before going on. Now, because this is a speech and not a conversation, some of the integration of verbal and non-verbal behavior is different, but some is also strikingly similar. For example, although nobody else is taking a turn, Papert still gazes away before taking the turn and gazes toward his audience as he begins to speak. Likewise, he gazes away at the end of this particular unit of the discourse, and then turns back as he continues. Papert also still uses all four kinds of gestures, beat gestures, in fact, although not illustrated here, are particularly EBSCO host, printed on the 2nd of May 2021 1:08 am via Tamperine Iliapiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 23 frequent in speeches. His gestures are still aligned with the most prominent phonological units of his speech, and there is co-articulation such that the first gesture, a deictic, perseverates through his speech disfluency, allowing the second gesture, an iconic, to co-occur with the semantic unit it most resembles. 1.8 To conclusion, one of the motivations for embodied conversational agents, as for dialogue systems, before them comes from increasing computational capacity in many objects and environments outside the desktop computer, smart rooms, and intelligent toys, in environments as diverse as a military battlefield or a children's museum, and for users as different from one another as we can imagine. It is in part for this reason that we continue to pursue the dream of computers without keyboards, which can accept natural untrained input and respond in kind. In situations such as these, we will need natural conversation, multiple modalities, and well-developed characters to interact with. We still cannot build an embodied conversational agent with anything like the conversational skills of Mike Hawley or Seymour Papert. Our models of emotion, of personality, of conversation are still rudimentary. And the number of conversational behaviors that we can realize in real time using animated bodies is still extremely limited. But, as we begin to understand the abilities that underlie human conversation, and to appreciate the behaviors that make up human conversation, we approach the day when a face-to-face Turing test will become imaginable. 6. Notes. Research leading to the preparation of this chapter was supported by the National Science Foundation Award IS 961A939, AT&T, Deutsche Telekom, and the other generous sponsors of the MIT Media Lab. Thanks to Andrew Donnelly for so ably handling the administrative aspects of this project, to all of the students of the Gesture and Narrative Language Research Group for dedication above and beyond the call of duty to this book, as to every other project we undertake, and to David Mindel and Kathy O'Connor for providing intellectual and physical contexts for writing. Finally, profound and heartfelt thanks to David McNeil for introducing me to this field, sharing his passion about the topic, and teaching me so much about scholarship and academic community. 1. Following Takeuchi and Nagao in 1993, we used the term of facial display rather than facial expression to avoid the automatic connotation of emotion that is linked to the latter term. 2. Square brackets indicate the extent of speech that is accompanied by a nonverbal behavior. EBSCO host, printed on the 2nd of May 2021 1:08 am via Tamperine Iliapiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 24-3. This description is, of course, an oversimplification of a topic that is still the subject of vigorous debate. I do not pretend to a complete theory that would, in any case, be beyond the scope of this chapter. 4. We call these behaviors envelope to convey the fact that they concern the outer envelope of communication, rather than its contents. Castle and Thoresen 1999. A similar distinction between content and envelope is made by Takeuchi and Nagao 1993, when they refer to the difference between object-level communication irrelevant to the communication goal and meta-level processing relevant to communication regulation. 5. Content nods tend to be fewer and produced more emphatically, and more slowly than envelope nods. Duncan 1974. 6. Parts of this chapter appeared in somewhat different form in Castle, 2000. References Argyll, M., and M. Cook. 1976 Gaze and Mutual Gaze Cambridge, Cambridge University Press. Bavelas, J. N., Chauville, L. Coates, and L. Rowe. 1995, Gestures Specialized for Dialogue. Personality and Social Psychology Bulletin 21, 4394405. Bavelas, J. N., Chauville, D. Laurie, and A. Wade. 1992, Interactive Gestures. Discourse Processes 15:46949. Beatty, G. W. 1981. Sequential Temporal Patterns of Speech and Gaze in Dialogue. In T. A. Sebiok and J. Umika Sebiok, eds, Nonverbal Communication, Interaction, and Gesture, Selections from Semiartica, 29830. The Hague, Mouton. Bolt, R. A. 1980. Put that there, voice and gesture at the graphics interface. Computer Graphics 14, A. 326270. Bregeler, C. H. Hild, S. Mankey, and A. Weibel. 1993, Improving Connected Letter Recognition by Lip Reading. In Proceedings of the International Conference on Acoustics, Speech, and Signal Processing IEEE ICASP, Minneapolis, Min. Brennan, S., and E. Hulteen. 1995, Interaction and Feedback in a Spoken Language System, a Theoretical Framework. Knowledge-Based Systems 8.231435151. Castle, J. 2000. More Than Just Another Pretty Face, Embodied Conversational Interface Agents. Communications of the ACM. Forthcoming. Castle, J. and S. Prevost. Any Embodied Natural Language Generation, a Framework for Generating Speech and Gesture. Forthcoming. Castle, J. and M. Stone. 1999, Living Hand-to-Mouth, Theories of Speech and Gesture in Interactive Systems. In Proceedings of the AAI Fall Symposium on Psychological Models of Communication in Collaborative Systems, Cape Cod, Mass. 3442. EBSCO host, printed on the 2nd of May 2021 1:08 a.m. via Tamperine, Iliapiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 25 Castle, J. and K. Thoresen. 1999, The Power of a Nod and Glance, Envelope versus Emotional Feedback in Animated Conversational Agents. Journal of Applied Artificial Intelligence 13, 3519538. Castle, J. D. McNeil, and K. E. McCullough. 1999, Speech-Gesture Mismatches, Evidence for One Underlying Representation of Linguistic and Non-Linguistic Information. Pragmatics and Cognition 7, 1134. Castle, J. C. Pellishow, N. Badler, M. Steedman, B. Acorn, T. Beckett, B. Duville, S. Prevost, and M. Stone. 1994, Animated Conversation, Rule-Based Generation of Facial Expression, Gesture, and Spoken Intonation for Multiple Conversational Agents. Computer Graphics SIGGRAPH Proceedings 1994, 41340. New York. ACM SIGGRAPH. Castle, J. O. Torres, and S. Prevost. Any Turn-Taking versus Discourse Structure, How Best to Model Multimodal Conversation. In Y. Wilkes, E. Machine Conversations. The Hague, Kluwer. Forthcoming. Chauville, N. 1992. Discourse-Oriented Facial Displays in Conversation. Research on Language and Social Interaction 25:163194. Collier, G. 1985. Emotional Expression. Hillsdale, N.J., Lawrence Albaum Associates. Condon, W. S., and W. D. Oskton. 1971, Speech and Body Motion Synchrony of the Speaker-Era. In D. H. Horton and J. J. Jenkins, eds, The Perception of Language, 1501A4. New York, Academic Press. Dittman, A. T. 1974. The Body-Movement Speech-Rhythm Relationship as a Cue to Speech Encoding. In S. White's, E. Nonverbal Communication. New York Oxford University Press. Duncan, S. 1974. Some Signals and Rules for Taking Speaking Turns in Conversations. In S. White's, E. Nonverbal Communication. New York, Oxford University Press. Afrin, D. 1941. Gesture and Environment. New York, King's Crown Press. Ekman, P. 1979. About Browse, Emotional and Conversational Signals. In M. von Krenach, K. Fopper, W. Lepanese, and D. Plug, eds. Human Ethology, Claims and Limits of a New Discipline, 169249. New York, Cambridge University Press. Ekman, P. and W. Friesen. 1969, The Repertoire of Nonverbal Behavioral Categories, Origins, Usage, and Coding. See Miatica 1:4998. 1984, Unmasking the Face. Palo Alto, Calif., Consulting Psychologists Press. Eliot, circa 1997. I Picked Up Catapia and Other Stories, a multimodal approach to expressivity for emotionally intelligent agents. In Proceedings of the First International Conference on Autonomous Agents, a Marina Del Rey, Calif., 451457. EBSCO host, printed on the 2nd of May 2021 1:08 a.m. via Tamperine Iliopiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 26. Hajakova, E. and P. School. 1987, The Ordering Principle. Journal of Pragmatics 11:435454. Halliday, M. 1967. Intonation and Grammar in British English. The Hague, Mouton. Hinrichs, E. and L. Poligny. 1986. Pointing the Way: A Unified Treatment of Referential Gesture in Interactive Contexts. In R. Farley, P. Farley, and K. E. McCullough, eds, Proceedings of the Parasession of the Chicago Linguistics Society Annual Meetings, Pragmatics, and Grammatical Theory. Chicago, Chicago Linguistics Society. Iverson, J. and S. Golden Meadow. 1996. Gestures in Blind Children. Unpublished manuscript, Department of Psychology, University of Chicago. Johnson, M. J. Bransford, and S. Solomon. 1973. Memory for Tacit Implications of Sentences. Journal of Experimental Psychology 98 A1203U05. Kendon, A. 1972. Some Relationships Between Body Motion and Speech. In A. W. Siegman and B. Pope, eds, Studies in Dyadic Communication. New York, Pergamon Press. 1974. Movement Coordination in Social Interaction. Some examples described. In S. White's, E. Nonverbal Communication. New York, Oxford University Press. 1980. Gesticulation and speech, two aspects of the process. In M.R.K.E., the relation between verbal and nonverbal communication. The Hague, Mutan. 1993. Gestures as illocutionary and discourse structure markers in Southern Italian conversation. In Proceedings of the Linguistic Society of America Symposium on Gesture in the Context of Talk. Krauss, R. P. Moral Samuels, and C. Colasanti. 1991. Do conversational hand gestures communicate? Journal of Personality and Social Psychology 61 574374. Levault, W. 1989. Speaking from Intention to Articulation. Cambridge, Mass., The MIT Press. Luperfoy, S. ND Spoken Dialogue Systems. Cambridge, Mass., The MIT Press. Forthcoming. McNeil, D. 1992. Hand and Mind, What Gestures Reveal About Thought. Chicago, University of Chicago Press. N.D. Models of speaking are to their amazement, meet speech synchronized gestures. In D. McNeil, E. Language and Gesture Window into Thought and Action. Hillsdale, N.J., Lawrence Albaum Associates. Forthcoming. Nickerson, R.S., 1976. On Conversational Interaction with Computers. In R. M. Baker and W. S. Buxton eds. Readings in Human-Computer Interaction, 6A1693. Los Altos, Caliph, Morgan Kaufman. Pellishow, C. N. Badler, and M. Steedman. 1996. Generating Facial Expressions for Speech. Cognitive Science 20-1146. EBSCO host, printed on the 2nd of May 2021 1:08 a.m. via Tamperine Iliapiston Cajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 27 Picard, R. 1998. Affective Computing. Cambridge, Mass., The MIT Press. Rhyme, born in 1982. The Elimination of Visible Behavior from Social Interactions, Effects of Verbal, Nonverbal, and Interpersonal Variables. European Journal of Social Psychology 12:113129. Scherer, K. R. 1980. The Functions of Nonverbal Signs in Conversation. In R. N. St. Clair and H. Giles, eds. The Social and Psychological Contexts of Language, 2523. Hillsdale, N.J., Lawrence Albaum Associates. Takeuchi, A. and K. Nagao. 1993. Communicative Facial Displays as a New Conversational Modality in Proceedings of Inter-CHI, Amsterdam, 187193. Wilson, A. Bobick, and J. Castle. 1996. Recovering the Temporal Structure of Natural Gesture. In Proceedings of the Second International Conference on Automatic Face and Gesture Recognition, IEEE, Killington, V.E. EBSCO host, printed on the 2nd of May 2021 1:08 a.m. via Tamperine Iliapiston Cajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 28. I Systems. EBSCO host, printed on the 2nd of May 2021 1:08 a.m. via Tamperine Iliapiston Cajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 29 2 Human Conversation as a System Framework. Designing Embodied Conversational Agents. Justine Castle, Tim Bickmore, Lee Campbell, Hannes Wilhelmsen. and Haoyang 2.1 Introduction. Embodied conversational agents, ECAs, are not just computer interfaces represented by way of human or animal bodies. And they are not just interfaces where those human or animal bodies are lifelike or believable in their actions and their reactions to human users. Embodied conversational agents are specifically conversational in their behaviors, and specifically human-like in the way they use their bodies in conversation. We describe an architecture that meets the constraints, and an implementation of the architecture that therefore exhibits many of the properties and abilities required for real-time natural conversation. We describe an architecture that meets the constraints, and an implementation of the architecture that therefore exhibits many of the properties and abilities required for real-time natural conversation. EBSCO host, printed on the 2nd of May 2021 1:08 am via Tamperine Iliapiston Kajasto, Tampere University Library. All use subject to https://www.ebsco.com/terms-of-use. Page 30. Research in computational linguistics, multimodal interfaces, computer graphics, and autonomous agents has led to the development of increasingly sophisticated autonomous or semi-autonomous virtual humans over the last 5 years. Autonomous self-animating characters of this sort are important for use in production animation, interfaces, and computer games. Increasingly, their autonomy comes from underlying models of behavior and intelligence rather than simple physical models of human motion. Intelligence also refers increasingly not just to the ability to reason, but also to social smarts, the ability to engage a human in an interesting, relevant conversation with appropriate speech and body behaviors. Our own research concentrates on social and linguistic intelligence, conversational smarts, and how to implement the type of virtual human that has the social and linguistic abilities to carry on a face-to-face conversation. This is what we call embodied conversational agents. Our current work grows out of experience developing 2 prior systems: Animated Conversation, A Castle et al. 1994, and Ymir Thoresen 1996. Animated Conversation was the first system to produce automatically context-appropriate gestures, facial movements, and intonational patterns for animated agents based on deep semantic representations of information, but it did not provide for real-time interaction with a user. The Ymir system focused on integrating multimodal input from a human user, including gesture, gaze, speech, and intonation, but was only capable of limited multimodal output in real time. We are currently developing an embodied conversational agent architecture that integrates the real-time multimodal aspects of Ymir with the deep semantic generation and multimodal synthesis capability of animated conversation. We believe the resulting system provides a reactive character with enough of the nuances of human face-to-face conversation to make it both intuitive and robust. We also believe that such a system provides a strong platform on which to continue development of embodied conversational agents. And we believe that the conversational framework that we have developed as the underpinnings of this system is general enough to inform development of many different kinds of embodied conversational agents.